Hello and welcome to Century Equipment's webinar series, where we explore different sampling related topics and provide more information about why sampling is so beneficial to the markets we serve. Today, we will be interviewing Joanne Carpenter from Colorimetric. Colorimetric manufactures ampules for simplified water testing analysis to the boiler and cooling water, chemical processing, and drinking water plants to ensure that their online analysis is working correctly. Joanne Carpenter is the head of research and development. She ensures that all of these ampules are not only performing as expected, but also ensures that there are new testing capabilities and products in the Colorimetric line. Today, we will be discussing dissolved oxygen and the importance of utility companies minimizing dissolved oxygen in their processes. So it's about time we get started. Let's welcome Joanne Carpenter.
Good morning, Kate. Thank you very much for inviting me to this podcast. I am the Director of Research and Development at Colorimetric Incorporated. We manufacture test kits for water analysis for a variety of parameters, many of which are of concern to water treatment engineers in the power plant industry. One of our most used test kits is for the measurement of low levels of dissolved oxygen, which we're going to talk about today.
So you said we're going to talk about dissolved oxygen. So at its core, what is dissolved oxygen?
Well, as everyone knows, oxygen is a gas and it's all around us and it supports life on Earth. Oxygen can also be dissolved in water and supports aquatic life. But dissolved oxygen in industrial water treatment is a whole nother matter.
You noted that dissolved oxygen in power and utility companies is a whole nother matter. So why is it important for power plants to monitor dissolved oxygen?
Power plants maintain boilers that produce steam that drive turbines, and then turbines in turn produce electricity. Dissolved oxygen is the primary corrosive agent in boiler systems, and water treatment engineers at these plants must control it in order to minimize corrosion effects.
So what happens if power plants do not properly monitor for dissolved oxygen?
Well, even low concentrations of DO can lead to highly destructive corrosion events. The corrosion can become localized and lead to pitting, which is essentially forming a hole in the metal surface. Over time, an oxygen scab can form in these places. And even when good water quality is maintained from that point, the corrosion effects will continue and will lead to costly downtime and inefficiencies. The high temperatures and pressures that are found in boilers actually accelerate the rate of corrosion. So operators, particularly of high pressure boilers, try to eliminate DO entirely from the steam feed water.
So if power plants are trying to eliminate dissolved oxygen, or as much as they can, how can power plants do that? What methods do they go about into removing dissolved oxygen?
Well, operators take two approaches. The first is using mechanical deaerators. This is the most economical way to try to eliminate oxygen from the feed water. The deaeration equipment heats water, and then the gases are vented, and the gases include oxygen. A properly maintained deaerator can actually drive down the oxygen level to parts per billion level. The second approach to supplement mechanical deaeration is to use chemical additives that are known as or function as oxygen scavengers. These include carbohydrazide, DHA, and hydrazine. And what they do is they react with oxygen to take it out of the system. Theoretically, maintaining a high oxygen scavenger level should be enough to eliminate oxygen. But in practice, it isn't really practical to do that because oxygen is reacting with metal surfaces. So there are competing reactions within the boiler system. So it's not really economically feasible to slam the system with high levels of oxygen scavengers.
So you mentioned the two ways that they try to control it, and how there's still room for, error on different parts. How can they monitor to make sure that these mechanical and chemical deaeration can still be effective?
That's right. It's crucial for plant operators to monitor DO levels to confirm that there's been sufficient removal from their system. Analyzers or probes are commonly used, and there are different types. Some of these rely on galvanic measurement or polarographic or amperometric. There are also another category of oxygen sensors that rely on optical means to measure DO. These types of sensors are permanently mounted in line, and they continuously monitor DO. They are typically calibrated based on water saturated air. And the calibration frequency depends on the vendor guidance and the sensor type and the type of water quality which the sensor is exposed to. Usually, it's recommended that the plant engineers periodically compare their online data to an alternate test method to make sure that equivalent test results are obtained. And this way, they will be aware of instances where the sensor has drifted, or it could indicate when the sensor has been exposed to corrosion itself or been fouled. Portable colorimetric test kits are available, and they are sensitive. Some of them are sensitive enough to measure parts per billion levels of oxygen. And they can be used to as the alternate method of measurement to compare the online measurement with. Plant engineers or operators will evaluate their plant and consider equipment performance, and reliability, and measurement frequency to determine the most suitable methods of measurement for their plant.
So by utilizing a recommended steam and water analysis system with these offline products such as Colorimetrics, what are power plants gaining by doing these?
The Chemetrix low-level dissolved oxygen test kit comes equipped with everything you need. It offers the advantage of being portable and being able to take DO measurements at different points in the boiler system. And this is often helpful when the engineers are trying to determine whether there's a leak in the system. The test kit is based on using a glass ampule, which is sealed under vacuum. And when the tip of the ampule is immersed in the water sample and snapped off, the contents of the ampule fills with the water sample. The reagent, the oxygen-sensitive reagent inside the ampule, then turns pink. The dye inside of the ampule is called rhodazine D. The test kit provides a means to sample the water, because one of the key elements of effective, accurate, low-level dissolved oxygen testing is making sure that the water sample is not exposed to oxygen in the air, which will, of course, contaminate it and produce high false test results. So the kit provides a sampling tube, which is hooked to a line that is carrying the feed water. The feed water has to be cooled down to ambient temperature before it can be measured. So the water sample flows through the sampling tube, and the ampule can be inserted within the tube for effective measurement. Lots of the ampule reagents that Chemetrix produces go through a rigorous quality control test where they're tested against certified oxygen gas standards, and we have rigorous pass criteria before they're released to our inventory. So operators can be assured that the test results will be accurate.
That is important.
One last piece of information is that there's an ASTM reference method that cites the Chemetrix oxygen test kit as the sole source provider for the measurement.
Well, thank you so much for your insight today. And we appreciate learning more about Chemetrix and dissolved oxygen. If you guys would like to learn more about Chemetrix and their products, there will be a link in the description below. And we will also link to our swaths and different probes that we have as well that work very well in line with Chemetrix products. So thank you so much for your time.
And it was great talking to you, Kate.
Yes, nice talking to you. You have a wonderful day.
Thank you. Bye-bye.
Bye.